Passengers are at life and death risk when planes are badly built.
Hydraulics, we lost it!
When engineers make mistakes.
This tragedy is not an accident.
Seconds after takeoff, this plane flips out of control.
This broke every rule in the book.
Hidden errors destroy this jumbo jet. Every crash holds lessons that cannot be ignored.
Somebody's got to stand up and say, come on, people, let's do the right thing.
But some engineering solutions can lead to further unexpected problems. How does the aviation industry battle to eliminate engineering error? JFK Airport, New York. It's the end of a hot July day. TWA Flight 800 is waiting to depart for Paris. It finally takes off just after 8 o'clock in the evening. There are 230 people on board. Among them, Jill Zimkowitz is on her first overseas trip as flight attendant. Jill's brother, Matt, air safety campaigner.
It was a regular day, it was a beautiful day, and Jill was so excited about flying to France that she told everybody that she was doing it.
In Jill's care is a group of 16 high school students from a small town in Pennsylvania. They're off to see the sights of Paris on the biggest journey of their lives. As they settle in, the plane climbs up towards its cruising height. "14,000 feet above the Atlantic, TWA 800 and everyone on board is blown out of the sky. The plane's last moments were seen by hundreds of eyewitnesses.
We saw a big giant ball of flames, biggest orange ball I ever saw.
My son was standing there on the beach and he said, "Oh, look," and we saw an explosion. We turned and looked at what looked like fireworks that were in the sky.
And I looked up and I saw what appeared to be a glowing ball.
Flight attendant Jill's body is one of the first to be recovered. All 230 people on board the Boeing 747 are dead. Following the eyewitness reports, many suspect the plane was brought down by a missile or a bomb. The FBI tell the public it's terrorism.
We know there was a catastrophic explosion. It's caused by some sort of a bomb, obviously. We're not further describing where that would be, whether it was carried on or something hit the plane from outside and caused it to explode.
But the crash investigators need to be sure. They have a difficult, delicate task. First, they have to remove the victims' bodies. Then recover thousands of pieces of wreckage. Each one a potential clue. At 100 feet down, each diver can only work for a short time. After 7 days searching, they find the plane's black boxes.
Excuse us.
Immediately, the investigators' hopes rise. Both voice and data recorders have survived the impact.
About 11 1/2 minutes after takeoff, the recording ended abruptly.
That abrupt stop is a clear indication of a catastrophic event, but that was all the investigators could tell. The recorders appear to hold no further clues. To find out what happened to TWA 800, the crash investigators begin the painstaking task of reassembling key parts of the jumbo jet. An extraordinary 95% of the plane has been recovered. And soon, they can come to one definite conclusion. TWA 800 was not brought down by terrorists. Jim Wildey was the team's materials expert.
It became pretty clear within the first month of the investigation, and even maybe sooner than that of all the pieces that were being recovered, not one single piece contained any evidence of a bomb or a missile.
But now there's a new puzzle. If it wasn't terrorism, what has gone wrong with this plane? Investigators start the long process to establish the cause of the crash. Is it possible that a plane designed to be fail-safe could be the victim of engineering error? It's one of the man-made catastrophes of the modern world. Hundreds of lives lost, billions of dollars wasted because a plane's not fit to fly, because of engineering error. But the need for safety has always vied with the need to make money. The boom in air travel triggers a boom in aircraft construction. And competition is fierce. In 1970, McDonnell Douglas unveils its new star, the DC-10. After $1 billion investment, they're convinced it's both safe and a future moneymaker.
The great DC-10, flying with pride.
Springtime in Paris. At Orly Airport, father of 5, Francois Drouin, is setting off on a business trip. His son Bruno was then just 5 years old.
I remember that Sunday that we drove our father to Orly. My father was taking a plane to London for his job. He was working for an oil company.
But Bruno's father's flight from Orly Airport has been cancelled because of a strike on a British airline. One of the only planes available is Turkish Airlines Flight 981, just arrived from Istanbul and on its way to London. It's a DC-10. Just 2 years old.
Because of this unexpected strike, many people took that plane, and so for that reason this plane was full.
The Turkish Airlines DC-10 is held in Paris, so it can take on passengers stranded by the strike. Unknown to his family, Francois Drouin also gets on board. Captains Ulusman and Burkos complete their pre-flight checks. At the back of the plane, Mohammed Mahmoudi, baggage loader, closes the cargo door. The DC-10 is finally ready to leave for London. Flight 981 is cleared for takeoff just after 12:30 in the afternoon. Everything appears normal. until the plane approaches 12,000 feet.
What was that?
Gusts of cold air rip past the passengers.
Cabin blew out. I can bring it up. She's not responding. Hydraulics? We lost it. Feet.
Just outside Paris, the plane smashes into the ground at almost 500 miles an hour. All 346 passengers and crew are killed.
It was a very, very violent impact. And the French authority as well were not prepared for such an event. It was the first one.
Bruno's family fear the worst for their father, but they still don't know whether he'd switched planes.
The passenger manifest was not complete, so when it happened, they couldn't get clear information. The proof of my father's presence in this plane was identified through his wedding ring that had been found on a fragment of his hand, and in which it was the date of the wedding of my parents and the first name of my mother.
Bruno was just one of many children who lost a parent. In the aftermath, the French investigators begin the dreadful process of looking for clues amongst the wreckage. But then the investigators get their first major clue. 10 miles from where the plane came down, French police discover a macabre scene. 6 dead passengers strapped into 2 rows of seats. Alongside them, a mangled piece of wreckage. It turns out to be the rear cargo door. But how could a door just fall off a plane? The answer would turn out to be engineering error. The investigators now focus on the issue of pressurization. Jet aircraft fly at high altitude, where the air pressure is very low. To keep the passengers comfortable, the interior of the plane has to be kept at a higher pressure.
If the cabin was not pressurized, the passengers would be exposed to an altitude higher than Mount Everest.
So it's crucial the DC-10's doors are designed to be airtight. During flight, the pressurized air inside the plane is pushing against the doors, trying to force them open. David Learmount is a pilot and an expert on aviation issues.
These doors, of course, are very large. You know, they're very, very large doors indeed. So if they open in flight, you've got a hell of a big hole in the aeroplane.
To prevent the cargo doors being blown open, the DC-10's engineers designed an elaborate locking mechanism. Pushing an external lever rotates claws on the inside, so they catch around a bar. It should have been totally reliable, but it was not.
The design fault was this. You could actually operate the lever, and it felt as if it had locked. But it could have failed to lock completely.
Investigators find that the door lever could appear to be properly closed, even though the locking claws were not being held in place. It's a clear example of engineering error. The investigators start to piece together an horrific chain of events. It all starts with the door's failing locking mechanism.
Basically, they were doomed from that moment on, because when the cargo door blew out, all of the air in the cargo hold beneath the cabin floor exited this very, very large hole.
The blowing out of the cargo door was the first disaster. Then the pressurized air in the cabin also tries to escape to the outside, smashing a hole in the cabin floor. It's this violent rush of air which sweeps 6 passengers out of the plane to their deaths. Those were the 6 people found 10 miles from the main crash site, still strapped to their seats. The collapsing cabin floor leads to a further disaster. It destroys vital control cables.
Hydraulics? We've lost it!
These cables work with hydraulic pressure to move critical parts, like the rudder and stabilizers. Without them, the pilots are unable to fly the plane.
I can bring it up. She's not responding.
So the pilots had no control over the airplane any longer. They literally couldn't tell the airplane any longer what to do.
Years later, in memory of all those who died, Bruno wants to find out the full story behind the crash that killed his father. From all the available evidence, it's clear to him that this wasn't an accident. It was caused by engineering. That's a frightening 138 aircraft.
I have no choice but to ground all U.S. DC-10s immediately.
The blame for the cracks falls on the airlines, not on the plane's manufacturers, McDonnell Douglas. But then the investigators discover another critical error. And that error has to do with fail-safe design. The idea that if there's a catastrophic failure, the pilot should still be able to control the plane. It all goes back to the moment when the plane banks to the left. That happens because the engine coming off ruptures vital hydraulic control lines, operating slats on the wings.
When the engine tore itself away from the wing, it destroyed the hydraulic system which kept those slats extended. When the slats retracted, because they had no longer hydraulic pressure to keep them out, that wing lost lift.
Just like in the Turkish Airlines incident, the plane crashes because pilots lose control. The lesson of fail-safe construction has not been learned.
That is not in the best traditions of aircraft design. Aircraft design is supposed to be based on what they call fail-safe. If it fails, the aircraft's still safe. This broke every rule in the book.
Over the next few years, the DC-10's engineers do learn this lesson. They install mechanical systems to make the DC-10s safe. But they can't patch up the plane's damaged reputation. Today's DC-10s are mainly used as cargo planes. It is Boeing's 747 Jumbo that becomes the world's most successful passenger jet. Its engineers seem to have learned the lessons of fail-safe design. Until that July evening in 1996, when TWA Flight 800 blows up, killing all 230 passengers and crew. After months of painstaking work, the crash investigators have reassembled entire sections of the shattered plane. Once they'd ruled out the possibility of a missile or a bomb, they search for the source of the explosion in the plane itself. Eventually, they find it. The central fuel tank has blown up. So what had done it? It didn't take long to identify the culprit. It was right there in the tank. Fuel vapor. When Boeing's engineers designed the 747 in the 1960s, the plane was expected to fly with all its tanks full. But when fuel prices rose, the airlines had to cut their costs. Christine Negroni has written extensively about TWA 800.
As we started to get more concerned about our use of fuel in the 70s and the 80s, airplanes stopped flying with full fuel tanks. If they didn't need the fuel, the tank went empty.
But investigators discovered that flying with empty fuel tanks posed a risk that had not been fully recognized. On that July afternoon, TWA 800 is sitting out in the baking heat at JFK Airport. To keep costs down, its central tank has just a puddle of fuel in it. And when that fuel gets hot, it turns into explosive vapor. This situation is made far worse by a second engineering error. Directly beneath the fuel tank, Boeing's engineers have put the plane's air handling units. These provide filtered air into the passenger cabin. But while they're making the passengers comfortable, these units are also giving off heat. And that heat is going straight into the fuel tank. The investigators now uncover a terrifying scenario. TWA 800 is climbing away from New York with a highly explosive fuel tank. The 230 people on board have no idea. It's like sitting above a bomb waiting to detonate. All it needs is a spark to set it off. But that's a risk Boeing's engineers thought they had eliminated. Their fail-safe design should have prevented it. They had made sure the only wiring allowed in the tank used a very low voltage. Not enough to cause the spark. Bob Swaim is a key member of the investigation team. He begins his hunt for the cause of the spark by taking another look at the cockpit voice recorder.
We came to realize that some of the background noise dropped out. Well, the energy didn't just disappear. It went somewhere.
Where the energy went was a short circuit. somewhere in the plane's wiring. And short circuits can cause sparks. But Bob Swaim's still puzzled. There's only low voltage wiring in the fuel tank. Even a short circuit shouldn't have been powerful enough to create the deadly spark. Looking for an explanation, Swaim and his team sift through the vast extent of the plane's wiring.
We examined 150 miles of wire from this one airplane, inch by inch.
What they find is some of that wiring is in a terrible state. And many different wires with cracked insulation are bundled together.
And this was really important because you could have wires that were powering electric lights with over 150 volts laying next to wires that would go to a fuel tank, which should never have more than 5 volts.
Swaim now realizes if the high voltage wiring is damaged, a dangerously high current could jump across into the tank's electrical system, causing the fatal spark. The investigation finally pieces together the sequence of engineering errors that brought down TWA 800. First, fuel vapor builds up in the tank. It's heated to a critical state by the air handling units. Cracked wires allow high voltage current into the tank. There's a short circuit, a spark, and the tragic result is the second worst domestic air disaster in America. Every year, families and friends meet to remember their loved ones killed on board TWA 800. But there is some compensation. Flight attendant Jill Zimkowitz and her fellow victims didn't die in vain. The authorities finally recognized the threat of exploding fuel tanks. With 1,200 other jumbo jets at risk around the world, they had to come up with a solution. New technology now replaces explosive vapor in the fuel tank with the inert gas nitrogen.
Overall, other than complaining about the slow pace at which safety changes are made in aviation, I'd have to say Flight 800 has a good legacy.
The TWA 800 investigation shows that a plane can have an excellent safety record until circumstances change. In the case of Flight 800, flying with an empty fuel tank exposes unforeseen risks in the plane's design. Aircraft engineers realize they have to get better at predicting problems.
The type of engineering issue which happens now in a good airline with a modern aeroplane is the type of engineering issue that has not been foreseen.
But is this going to be possible? In the 1990s, to minimize engineering error, Boeing begins using the very latest technology to design and build the 777, the world's largest twin-engine jet. Just like Boeing's original jumbo, it soon gains an impressive reputation for safety. But there is a shock in store for Boeing's engineers. They may have dealt with the risks of fuel getting too hot, but they will fail to predict what can happen when fuel gets too cold. Heathrow Airport on a normal busy day. Planes from all over the world landing every 3 minutes on the southern runway. Among those on its way into Heathrow is a British Airways 777. Flight 38 has 136 passengers and 16 crew on board. They've been flying for 11 hours through the night from Beijing, and everyone is looking forward to the end of the journey. Captain Peter Burkill and First Officer John Coward prepare for landing.
Okay, you have control, John.
I have control.
Everything is pretty much normal about a minute before the aircraft is due to touch down. It's at about 1,000 feet, the landing gear is down, the flaps are deployed at about 30 degrees. There's no indication there's anything wrong.
Speedbird 38, clear to land, 27 left.
Clear to land, 27 left, Speedbird 38.
Then at about 500 feet, just 35 seconds from landing,
I can't get power.
both engines suddenly lose power.
The airspeed is starting to drop back. This 200-ton aeroplane is effectively turning into a glider.
The passengers have no idea they could be about to die. And it could be even worse. Beneath them, there are tens of thousands of people at risk. Cab driver Johnny Rowland is on his way to pick up a passenger when the plane flies right above him.
It was a noise that I hadn't heard before. It was a whistling noise rather than an engine noise. Just as I got to this point here, the cab completely went dark with a shadow around the whole area. And as I looked out the right-hand window, I saw the plane was so low to the fence it could have only been 10 foot above the fence. And I said to myself, oh, you're going to crash.
Mayday, mayday, Speedbird.
Incredibly, all the passengers and crew survived the crash, with just a few minor injuries. The engineers are now desperate to find out why those two engines lost power. A double engine failure is extremely rare. Soon the plane's data recorders point them towards a very new kind of engineering problem. Something stopped fuel flowing to the engines. But what?
Something happened within the fuel system which had never been foreseen.
Back at their base, the investigators reassemble the plane's system of fuel pipes, but they can't find any physical obstruction. That leaves one other possibility. Ice. The plane's route from Beijing took it through some extremely cold air, down to minus 74 degrees Celsius. At these temperatures, the minute amount of water contained in aviation fuel can turn to crystals of ice. Had ice blocked the flow of fuel? At first, this seemed impossible. Ice is a well-known risk, and aircraft engineers thought they'd dealt with it. In the 777, they had made sure cold fuel is warmed up before it gets to the engine, in a device known as a heat exchanger. Steve Moss is a leading crash investigator and engine expert.
As the fuel flows through these tubes, it is heated so that as it comes out at the end here, it is actually above 0 degrees, so that ice crystals are not fed down to the engine.
So if this device was meant to melt any ice crystals, how could they have blocked the flow of fuel? The investigators then go back to the flight data recorders. They study what was happening in the fuel system during the long flight from Beijing. They then simulate the impact of cold weather on the fuel pipes.
Well, the testing showed something which had not been taken into account. During cruise, when the fuel flow is pretty sluggish, ice can actually accumulate inside the pipes.
Approaching Heathrow, the pilots need more power from the engines. This sends a sudden surge of fuel through the pipes, dislodging the ice.
And it becomes a sort of snowball, or more likely an avalanche, getting bigger and bigger as it travels towards the engine.
The snowball smashes into the heat exchanger and blocks it. Just as the plane needs more power, the fuel can't get past the ice. The engines are useless.
Designers thought they'd thought of everything, but there was one circumstance they didn't even know could happen, and it's that.
Once again, it had taken a crash to reveal a problem the engineers had not foreseen. Now they know it can happen. It takes a very small alteration to the face of the heat exchanger to make sure even a sudden rush of ice can be melted. Today's engineers continue to strive to build much safer planes, and there are far fewer accidents due to engineering error.
Fatal accidents are 6 times rarer than they used to be 30 years ago. I mean, that is a quantifiable improvement.
The aviation industry is still young. Barely a century separates our modern jets from the first days of flight. For today's engineers, the challenge remains the same: to eliminate errors before they lead to disaster.